Okay, so here is an integral, a definite integral. It's the integral of 2x plus 4 dx from negative 1 to 2. And we're going to try and write it in summation notation. So let's begin. Negative 1 to 2, 2x plus 4 dx. Now remember, the summation notation is going to look like this. It's going to be the limit as n approaches infinity of the sum from I equals 1 to n of f of xi by delta n. Okay, so that's what our final answer should look like. Okay, sorry, delta x. I beg your pardon. So we're going to start off with calculating delta x. Okay, so let's change different colors because we're going to be doing quite a few different bits and pieces. So delta x is equal to b minus a over n. That's the top limit minus the bottom limit over n. So delta x is going to be equal to 2 minus negative 1 over n, or delta x is going to be equal to 2 minus minus 1, 2 plus 1 is 3 over n. So in other words, if we could imagine this graphically, each of the rectangles would have a width of 3 over n, where n is the number of rectangles that we use. Remember, that goes to infinity in this case, thinking about the theory of it. Okay, so that's delta x. The next thing to do is to work on getting an expression for xi. Okay, so well, what we do is we let x0 equal the bottom limit, okay, which is negative 1. So x0 is the bottom limit. Okay, x1 is negative 1 plus delta x, okay, which would be negative 1 plus 3 over n. x2 would be your first one, negative 1 plus 2 times delta x, which is negative 1 plus 2 times 3 over n. And if we continue that, we get xi is equal to negative 1 plus I times delta x, which is equal to negative 1 plus I times 3 over n. So xi is equal to negative 1 plus I times 3 over n. Now, on that, there is a little formula that you can use to get you there a little bit more quickly, if you like. And the little formula that can get you there is xi is equal to x0, which was the minus 1, and that's where the minus 1 comes in here, plus I times delta x. Okay? So we could have got there directly instead of getting there in steps and iterations. So if you remember this formula, that's a formula worth learning. And also, it's important to learn this formula. Okay? Now, it may not be good mathematical practice. You should understand where these things come from, but if you've been following the notes in class, then hopefully you're on your way to doing that. It's not an easy topic, though, so it's something where you may need to use extra resources as well. So we've got delta x. Okay, looking back up here at the top of the screen, we've got delta x, and we've got xi. We need f of xi. Okay, so that's the next thing. So f of xi. Right, well, first of all, look at f of x. F of x is this part of the question. Okay, it's the expression that is being integrated to the integrand. So f of x is equal to 2x plus 4. F of x is equal to 2x plus 4. So f of xi will be equal to 2 times minus 1 plus I times 3 over n. Okay? And now we have all the pieces that we need. we've got f of xi, we've got delta x, and this is standard. This bit is never going to change. Okay, this bit here is not going to change. Okay, so we finally finish off by writing, we're close to the end now, the integral from -1 to 2 of 2x plus 4 dx is equal to the limit as n approaches infinity of the sum from I equals 1 to n of, and then just look back up here to check it in, f of xi times delta x. So f of xi is 2 times -1 plus I by 3 over n by delta x, and delta x, if you look up here in orange, is 3 over n. Now if you want to multiply some of this out, you can do, but generally speaking, it's not required. And there you go. Okay? That is the expression, and obviously the integration on the left-hand side of that equation looks a lot simpler, but this on the right is where the idea of integration comes from. Okay, thanks for watching.